Hey, what's up, guys? Welcome back to the Code Path to Pro. Today is Monday, February 5th, 11 a.m. Hope y'all are doing well. Yeah, got about 45 minutes, and I'm gonna hit the gym, and then I got an interview, so let's get into it. Hope y'all had a good weekend. Let's try the daily out for size. Let's see how it's going. Um, yeah, we missed the dailies a bit. Okay. It's an easy. I assume I've done this, yeah. Given a string S, find the first non-repeating character. Okay. Yeah, I mean, there's a few different ways you could do this. I think I'm just going to use 2 pointers. Or, oh, no, you do have to do a hash map. So, cause hash map counts. Do a hash map for character in S. Guess we just do a counter. You do that in Python counter. Counter string. So now if we print counts, let's just return 0. We get something like this. Yep. All right, well, there's 4 E's in there. Okay, so then, and outside of this, we can just return 1. Let me say for I in range of S. Right, we iterate through our string, but we want the indexes. I mean, we could do it with this. C. Right, that's really up to you. Enumerate, so that's going to give us a counter, a pointer, index counter, and the actual character we're looking at. If counts of C less than the 1, right, we just want to return I. And then that should do it. Yeah, pretty straightforward problem. It's pretty efficient. Let's see what they pull up. That's crazy. Oh, it's the same one. Oh, okay. But yeah. Let's see what other people have put. Mark Phillips Philo. Yeah. There's an advertisement. Wow. Crazy. R fine. That's so. This is a pretty cool. Pretty cool problem. Oh, oops. Now what I meant to do. Yeah, I mean this is exactly what this is exactly what I did. Yeah. No, so there is a space optimization you can make with this. Let's see. Let's do that in a crazy way. But yeah, that's the code. Let's see. Let's see if we can find it. This is so it's this guy. Yeah. Just counter. Counter just makes it a little easier. It's built in. But by all means, it just takes a few more lines of code with the hash map because you'd have to go through and fill that hash map. Yeah. Yep. So cool, we did that. That's where it was found. Yeah, let's go through and do one of these. I think I know which one to punish myself today. This guy. Oh yeah. All right, let's do this. Maybe we'll just do it. I think I've done this problem before. Yeah, I've solved this. Rotate image, spiral matrix, word search. We done this one. Solved it. It's like a fake solve. Alright. Let's do set matrix zeros. I think I solved this recently. Yeah. Yeah, like a month ago. Okay. So, yeah, this problem's cool. And it's it's in the Lecopath, or sorry, it's in the what's that book? I got a blank. Guide to, what's it called? Cracking the coding interview. Cracking the coding interview. But yeah, so the idea here is we want to set, if an element is 0, we want to set its entire row and column to zeros. So we just, you might think, okay, that's not so bad. The problem though becomes, let's say you loop through your matrix and you find a 0 and you go ahead and set everything. Well, if your setting is something to 0 that you haven't looked at already, and then you hit that and it has now been set to 0, it wasn't originally 0, its row and column shouldn't be set to 0, but because it's been turned 0, you might, your program might think that. So you just have to be kind of careful about the ordering, about how you go about doing stuff. So yeah, so what we're gonna do, this will say rows equal length of matrix, right? Matrix 0. Or no, this is it's the other way around, isn't it? Oh no, that's it. Yeah. And then going through. So we're gonna make an initial pass where basically the idea is we're gonna set everything. We're gonna set everything to 0 on the edges. So anything we encounter on the interior. So like here, this 0. Because it's, well, for this example, we wouldn't do anything in this first pass. For this example, what we're going to do is we only need to do the top right row and top leftmost column, top row, leftmost column. And if we count a 0, we'll set a 0 on this kind of edge piece here. That would be us kind of keeping track of, okay, this is where we need to set the zeros in the future. These are the rows and columns we need to set to 0 in the future. So I'm going to skip the first, and then we're going to go rows, row-wise, and for j in range 1, 2 columns, right? And here, if the length of our matrix is 3, we want to go, 1, yeah, 2, because it won't actually hit 3. Yeah, so this is exactly what we want. We say if matrix I j equals 0. It's an integer matrix, so it is 0. If that is the case, then we want to set matrix of 0j to 0 and matrix I 0 to 0, right? Yeah. So let's see what we get when we do that. So we're getting 1, 0, 1, 0, 0, 1, 1, 1, 1. So we're getting exactly what we want for that example. Case 2, there should be no change for case 2. And there is none. So we're doing this correctly, which is fantastic. Right. Okay, so now we need to loop through and look at this. We'll go column-wise first, right? So we'll say for I in range, well, we'll go row. Keep it standard. For I in range, I 1, 2 rows. So we want to skip this first one too, because we don't want to set the whole top column, the whole top row, which has where we're going to look at our columns. We don't want to set all that to zeros. So for I in range 1 to rows, what are we going to do? We're going to see if matrix matrix, we're looking at row-wise, so row will be I, column will be 0. We're just giving that first one information. I is 0 equals 0, then we're going to go ahead and set that whole row to 0, right? So then matrix so I remember this is where I struggled last time figuring out how to just loop through it. Make that the case. I mean, couldn't we just do it like this? Matrix of I for spot matrix of I. Do we need to do this? Right, because matrix of I, then we still want that row. No, we'll do this for J. Range. It's a little confusing for sure. Matrix of I of J equals 0. Alright, so now let's see what that gets us. Alright, so now 1, 0, 1, still right. This has now all been set to all zeros. Fantastic. This is yet to be set. Let's see here. So here, nothing should have changed still here. And nothing has changed. That's great. Okay. What is all this? Get all that crap out of there. So now we're going to go column-wise. Do this top column for J in range. Columns, if matrix of 0 j, okay, equals 0. Right, so now we're looking here, skipping that first one. Alright, I remember. Well, let's just finish this first, and then I remember the other two steps, I guess you have to do. So then, if matrix of 0j equals 0, so one of these bad boys, then we want to set everything in that column to 0. So for I in range of matrix, right? Because now we're at a specific column. We want to go through each row. So we set matrix of that row in the jth column to 0. Right. So now we should be seeing this guy. That can be kind of our indicator. And it looks like that one is. So it looks like that's correct. Case 1 is handled. That's great. Yeah, but then we still have one last piece. And actually, what I'm going to do before this is loop through we'll have a couple Boolean values. So top row equals false, top call, top row, or top call equals left row, right? If matrix of ith row, 0th column. We actually need to do this before all this. Equals 0. Then left row equals true. And then columns if matrix of 0 and then our j equals 0, then top call equals true. Alright, so we're handling all this, and now we need just one more check. If left row, we need to fill this left row, so for I in range rows matrix of I 0 equals 0. If top call for j columns matrix of 0 j equals 0. And now this should be running beautifully. Cool. Cool. So yeah, there's a decent amount of code. So this rows and columns. That's just getting the rows and columns. You don't need to do that. You could explicitly put for every row here, just replace it with length matrix. For every column, just replace it with length matrix 0. I like to do it. And then here I have the Boolean left row and top call. Basically that's, and then we're going through here and checking, are there any zeros, before you've done any editing on the matrix, are there any zeros in this leftmost column, or leftmost row, or this topmost column? And for this one, obviously yes, for this one, no. And then we loop through, we do our thing where we're looping through basically this part of the matrix, this part. We're ignoring these rows and columns. And if we find a 0, we're setting a 0 up in the top column and the left row. And then what we're doing, we're looping through, because we don't want this intersection value, because if we did handle this, and we set everything to zeros over here, this might be from a column value or a row value, we don't know, so we need to handle that with our Boolean values. But yeah, basically here we're just going through our rows, starting here, checking, okay, was there a set 0? If there is, we will set everything here to 0. Same thing with the columns, and then we just check, okay, if was there an original 0 in one of these placeholder spots we've been using? If there were, we'll set everything to 0. For that row and that column. Yeah. Cool. Not too bad, not too bad. I'm definitely getting a lot better at the matrix problems. Let's see. Yeah. Did something pretty much exactly similar. A little more funky with the, yeah, and you can break here. That's a good thing to add. I don't think it speeds it up too much, but definitely helpful. Yeah. Speeds it up a little bit. Yeah, but this is, O, we're not storing anything. It's O of 1 time, and then O of n times n, or O of n times m time, and O of 1 space. Yeah, this is cool problem. Yeah, I'm gonna do some Kaggle later, because I didn't do it yesterday. Yeah, so it'll be a double upload day. Pretty sweet. Oh, there we go. Oh, I think that was so much. I mean, like I said, this is definitely a little heavy on the, I guess not crazy. I mean, it's like, whatever, 30-something lines that you're writing. But, yeah, definitely a little bit heavy. N times M of 1 space. Well, they say, what's the strategy here? Order. Sure. Okay, here's a little string guy. Got 15 minutes left. Let's give this a shot. String guy. And select this. A phrase is a palindrome if after converting all considered letters. Ooh. Oh, interesting. So we have to clean the string first. After converting all. So is numeric. Non-alphanumeric. Yeah. Numeric is just fun. Is al num. Okay, so write that down. So what we're gonna do? Set. So we're gonna see is our scene. Set. Then we're gonna go through the character in S. If character is numeric. So if it's alphanumeric, then I guess we need to do this. C. Or lower. If C lower is alphanumeric, then if C lower that is in C lower in a scene, then we can say scene dot remove C lower else C dot add C lower. And then here we return true if length of C less than equal to 1 plus. Hmm. How is that false? Oh, does the order matter? Oh god, done. Huh. Oh, I mean, I guess if it's gotta be the thing, we don't need a set. Hmm. Yeah, so I mean, I guess we get rid of the scene. Check the result. Result. Pen. Lower. And then we have to do some more stuff. So now we have to make sure, because now we're gonna have a result like this, right? We'll just return. All right, so this is our result. Let's hit red. So now we can do like left, right, left equals 0 equals length of result. This one while left is if left or we need result of left is result right, we can ignore left. This one else false return true. Otherwise, all right. Cool. Cool. Yeah, there's definitely a better way to do this, you know? It's not great. Or it is pretty good. Ugh, that's gross. Yeah, but I mean, you know, I got some time, so I guess, you know, um, yeah, we can keep doing that. So we can kind of maybe ignore all this. Okay. We don't need this extra space. You know, this solution isn't any slower, but it's just uses the extra result space. So let's set string -1. All right, so then we say if string of left if numeric, then we want to compare left. Same thing with our right. And I'll just make that with space. String right. That is numeric it is. We can check if it'll work. It'll work. This maybe should work. If not, you do that. Yeah. Sure. And L less than S and R greater than 0. Let's see what we get. Then change it. False. Should be true. Let's see where that's L. That's R. What's going on here? It's a blank spot. Whoa. That's 6. 0, 1, 2, 3. Why is that? Is space? Yeah, how is that? Huh. Hmm. How is that? A0. And then it gets the space. That's so interesting. So it skips this guy. Oh. Yeah. This takes a while. Yeah. Hmm. That's fantastic. Okay. Cool. So this is the more ideal solution. Doesn't use extra memory. A little tricky to get there though, for sure. So yeah, what we're doing, we have our left and right pointers on either end of the string. We're checking, while the left pointer is not alphanumeric, we're going to just keep bumping it over, and also checking to make sure that it's not past right. Because if you had a string of all non-numeric alphanumeric characters, hit this condition, left will get bumped all the way out to an index outside of the string, and then we go to check that index of that string. That's going to throw an error, so we need to make sure we break this when left becomes equal to right. Same thing here. And then we just check if they're equal. They are, else we return false. And then we return true if we do not hit any stuff that breaks our solution. So yeah, this is cool. A little more optimal than what I was doing with that result. Yes. One memory. And then this is 2 pointer. Sorry. That is album. That is num. That lower. Yeah. Cool. 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 All right. Well, yeah, that's it for me today. See you guys.